Hi guys, Mr. T here. Today we're going to do a little video to help get the dust off of our linear equation solving skills, and also to use these examples to demonstrate just how big the numbers 1, 2, 3, and 4 of our big stuff, our big ideas, our big stuff as far as algebra is concerned. That's going to be our primary two objectives with this video, okay? It's a little interesting. We're all trying different things, so we're going to give this a shot today. And I realize it's kind of weird because you got to see this dude in the mirror. Best I could do. And that's just kind of where we're going to have to go. We're going to do the best we can do, and we'll get better. You know, that's how it goes. We'll get better as we go. And it's kind of got a reflection. So be it. You can see the screen. I'd rather you be able to see the screen. I just wanted to see you to see me a little bit with the interaction, so a little bit more personal. Okay. Now, so now that we got the intro part done, let's get this thing going here. So you should have, let me get to the right place here. You should have this screen up here. This did you hear about? That's the worksheet we're going to be working with. Okay, and then let's do a quick review of our big stuff. Number one being, because we've already done an overview in the previous video, what you do to one side, you're going to do to the other side of the equation for number one. Number two is always add and subtract like terms. Always, right? So never, ever unlike terms, correct? So, and then number three, we're going to multiply and divide all the way through, whether that be our parentheses, like distributive property, or through the entire equation, all the way through when we multiply and divide. And then to a lesser point, we're going to deal with solution. This concept of solution, it's bigger than just an answer. It's that which you can plug in that makes it true. You're going to want to memorize that exactly. Okay? But before we actually get through some of these examples, I know some people get really uptight because up to this point, a lot of your teachers may have said, this is step one, this is step two, this is step three, and step four. And when you're just learning, that's not a bad idea. But we're going to be trying to expand ourselves a little bit past that. And because not everything fits into a 1, 2, 3, here's how you go. But as we're transitioning into those kinds of ideas, I'm going to do a quick review of a strategy called GLAD that kind of helps you go with the steps through here, okay? GLAD, step through here. GLAD is a strategy that says simply we're going to start with grouping. We're going to start with grouping. That means you're going to either group the like terms together, or you're going to use distributive property through the parentheses. You're going to do your grouping symbols with like terms or parentheses. If you got a fraction, we're going to multiply through by the least common denominator, clear the fraction, we call that, and then that should set you up for adding, subtracting, and then multiplying, dividing last. Pretty good strategy. It works a lot of the times for a lot of situations. Not bad. So if you like having a kind of a step 1, 2, 3 step thing, GLAD can be a good resource for you. But it's not the primary point of what we're doing here. I just thought I'd give you just a little something for those of you who are kind of nervous with this crazy guy setting things up here. All right, our first example. Well, that dude's in the wrong way. We're going to put him over there. See? I turned him off, but then you couldn't see me at all, which could be a blessing. I don't know. But we're going to do this guy here. On our worksheet here, on numbers 1, 8, 11, and 12, I created some new equations that were almost just like it that should have basically the same steps, okay? But don't look to this being, hey, this is just how you do it, 1, 2, and 3, because I'm going to do each one of these probably twice and looking at different ways and different pluses and minuses, okay? But because our focus is we're going to solve these equations, yes, but we're doing it with the big ideas in mind. All right, so what is our goal here for this equation? Well, our goal is to get x by itself. We call that isolating the variable. Isolating, or get the x and then the equal and then everything else, right? So isolating the variable, that's our goal. To get that to happen, what's got to go? 2, 5, got to go away, okay? And if I'm going too fast, I'm trying to go as fast as I can to keep the video small, but you can always rewind, okay? All right, so 2 and 5 got to go away. Now, if I had a specific strategy, I would know which one to do, whatever. And as you get some experience, you're going to kind of know which one to do. But I don't really know. So I'm just going to start with 2, okay? So 2, in algebra, how do we get rid of things like that? We do the opposite operation. So this is 2 times x, so what's the opposite of multiplying? It's going to be dividing. So let's divide by 2. Okay, that's going to make that. So 2 over 2, yeah, that turns into x. Did I get rid of my 2? Yay, I got rid of my 2. But is that legal? Well, if I don't do some other stuff, it'd be illegal, because let's go back to our big stuff. Okay, what we do to one side, we got to do to the other. So, that means if we divide by 2 on one side of the equation, we got to do it over here too, don't we? All right, and then, so that's the big stuff number 1. Now, how about big stuff number 3 that says multiply and divide all the way through? Well, we got to do it all the way through then. So here's our, there's our 2. Oh, okay. So this turns into x. This turns into 5 over 2. Nice improper fraction, not a decimal. It doesn't start as a decimal, doesn't end as a decimal. Okay? And then over here, 22 divided by 2 is 11. Now, some of you are already groaning and getting upset. Oh, crap, what am I going to do? Oh, no. Oh, no. What am I going to do? Well, let me tell you. No big deal. Fractions, nothing to be worried about. Okay, one, you can learn how to do it. The other thing is we got these really nice calculators that do fractions pretty well. So I'll come open up my little calculator here, and this is a neat little version that says, but it's just like yours. And what I'm going to do is here, 11 minus, okay, and then 5 over 2. And I hit the alpha button and y equals. And you can see which buttons I'm hitting right through here, okay? And it sets up this, number 1, and then I put 5 over 2. Now, with the calculator, they can set this up. Why would you ever be scared of a fraction? No big deal. And you're not going to always have your calculator, but most of the time you will. So don't get uptight just because you have fractions. Deal with it. It'll be okay. So now we hit enter, and voila. I hit a button that didn't like it. So let's go back over here. Boop. And hit enter again. There we go. And of course, this little dude right here is in the way. And we got 17 over 2. 17 over 2. Well, best laid plans, you get what you get sometimes, okay? So 17 over 2. Worked out. If I could get rid of that, that'd be great. But not. So 17 over 2. Don't worry about it. Fractions are not a big deal when you have a nice calculator like we have. Let's back up over here. And so we said that answer right there ends up being x equals 17 over 2. All right. Now let's get this guy back out of the way. And I'm sure he'll jump in the way again later. All right, 17 over 2. That's the answer, guys. Promise you. We can plug it in and be great. But could there have been a different way to do this? Could there have been a different way? A different strategy we could have used? Okay? Well, absolutely we could have used a different strategy. Okay. So let's start this guy over. 2x plus 5 equals 22. Well, we're still trying to get this x by itself, right? That's still what you're trying to get by itself. However, this time, instead of dealing with the 2 first, I'm going to deal with the 5 first. So how do I get rid of 5? Well, that's addition, subtraction. So the opposite addition is subtraction. I'm going to subtract 5 from both sides. There we go. So let's go from left to right and deal with this. 2x just comes straight down. Positive 5, negative 5 does cancel. I beg you to double check that. Don't just write it down. Double check it before you go to the next step. Because if you had wrote plus 5 on both sides, you could do this addition on the right side so wonderfully, but it really would not matter one little bit, would it? It wouldn't matter one little bit. You would still have the wrong answer. So this is more important. Double check it. So let's subtract here. That's I think that's 17, right? Oh, this sounds familiar, doesn't it? Divide by 2. Okay. X equals 17 over 2. Either, see what I'm talking about? You can go different directions, different strategies, still get to the same answer as long as you don't break the basic rules. So that frees you up not to be so concerned sometimes. Now, some things we'll definitely talk about strategies that are much better than others. But right now I'm just trying to free you up to let you know that you're in control. You have just a few rules that you got to follow with these equations. You're in control. Try some different things. And when you're in charge of trying some different things, you will find things that seem to work better for you, and that'll help you remember better than me just telling you, do it like this, okay, kind of thing. That's what I want you to do. You're becoming more in control of what's going on there. And again, a simplified improper fraction is a beautiful answer. Now, I realize that's 8.5 or 8.5 on your worksheet, but 17/2 is what I will be looking for written down. Okay, let's go to another example. I can get there. Here we go. Example number 2, and we'll try to pick up the pace a little bit. So again, what is our goal here? We're trying to get this x by itself, but we can't get the x by itself if the x's aren't together in one spot, can we? So our first goal is going to be to get these x's together. Okay, so what's that going to be? That's 3x. Oh, that's minus 15x. So do we need to add 15x to both of these? No. We would only add 15x if it's on both sides of the equal sign. And it's not. It's just on the right-hand side. We're just combining like terms. That's all we're doing, combining like terms. So 3x minus 15x is going to give me negative 12x. Okay? Bring down my minus 8. Bring down the 44. So we combined our like terms. That's a good idea. Because again, our goal is to get x by itself, but you can't get it by itself if they're not together in the same place first. So that's just like arranging change and counting change. Concept, basic idea. Who wouldn't do that, right? So here we go. Now last time we started with the number with the x, didn't we? We really didn't like the results of that. So let's try the 8 this time. Let's try this number over here, and let's get rid of the 8. So the opposite of subtraction would be addition. So what we do to one side, we do the other. Okay? And so then we do this right here. Okay? All right. So 44 minus 8. Is that true? No, I forgot my plus, didn't I? There we go. There's plus. Plus, plus, plus. That's good. So 44 plus 8, well, that's going to be 52, right? 52. Okay? Some of y'all have been quite nervous about what I wrote, and if you were in class, you would have tried to correct me, which is not bad. Because what's wrong with this picture here? These aren't like terms, are they? Okay? Now, if this was multiplication or division, that'd be perfectly fine. But with addition and subtraction, that's completely illegal. That's big stuff number 2. You know, you've already busted it, and it's on number 2, right? So, no. So those aren't like terms. It helps us figure out what we are to do and what we can and can't do by the simple rules. So those cancel, bring down our negative 12x. Okay? So, again, we're trying to get x by itself. The opposite of multiplication is division. So what we can divide by negative 12. What we do to one side, we do to the other. Okay, we can divide both those by 4. We can use our fancy-dancy calculator. Either way, we're going to come up with negative 13 over 4. Okay? Negative 13 over 3, not 4, excuse me, over 3. So there's the deal with that guy there. So bring the terms together, not opposites, because we're not going to both sides yet. And then I decided to deal with the constant term by adding 8 to both sides and dividing by negative 12, and there would be my solution. So how do I know for sure it's my solution? Well, let's check it out. So we got this on 44 equals 3 times x minus 8 minus 15 times x. Well, a definite solution says that which you can plug in that makes it true, correct? So we're going to give it a shot. We're going to try to make it true. All right. I'm going to literally erase these x's and then put in negative 13 over 3. Negative 13 over 3. Okay, now I'm going to go over to my fancy dancy calculator here. So clear these things out so we can follow what's going on easier. So we have 3, open parentheses, negative alpha, y equals, and then have 13, down arrow, 3, come out of that. Oops, something went wrong. Missed my 1 there somehow. Then there's my 3. And there we go. Minus 8. Minus 15. Open parentheses. Alpha y equals. Negative 1, 3. Come on down. Why do I keep on missing that negative? Negative 1, 3. Okay. Down 3. All right. And then we close that parentheses off. And then hit enter, and we get 44. Is it 44? Great reveal. 44 it is. 44 it is. Now we have a solution because that which you can plug in that makes it true. So we plugged it in for x, made it true. So we're sure about our solution now. Okay? So we check that guy out. All right, example number 3. Okay. Oh my goodness, that looks like a really scary one, doesn't it? Oh my. Oh, well, it isn't that going to be that big a deal. But let's go back here. So we're going to try to trying to solve for x and get x by itself. So 8 and 3 have to go away. Last time we tried to deal with the constant first by adding and subtracting. That seemed to work better for us. Good strategy. So let's try that. So what we're going to do, subtract 8. Oh, can't do it. Why can't we do it? See this line here? That big old bar, that's a fraction bar that basically puts parentheses around that. So that has an invisible force field around it. Can't touch it. Cannot touch it. So we're forced to deal with the 3. Oh, well. Well, that's division by 3, right? What's the opposite of dividing by 3? Well, that'd be multiplying. So we're going to multiply both sides by 3. Well, okay. Well, these 3's cancel. And that gets it out of the force field, doesn't it? It releases it from the force field. And that's going to be negative, I think, 168. No, negative 39. That's the next problem. Okay, negative 39. Silly me. 3 times 3 is 9. Yeah. Oh, that looked like such an ugly problem, and now it seems like not big a deal. Just multiply times 3, pretty easy from here out. We're going to minus 3 here. What, minus 3 here? Could it do over there? No, because they're not like terms. Big step number 2, only add and subtract like terms. And some of you might be saying, it's no big deal. I know all that stuff to begin with. I'm going to tell you, many of the mistakes people will make come from the top 3 issues. What they do to one side, they don't do to the other. They add and subtract unlike terms, and they don't multiply and divide all the way through. The primary mistakes people make. You know, if they have any idea what to do at all, those are their biggest common errors. Okay, and it's stuff that we know better to we can fix. So let's try to make it a big deal so we can rely on those things. So here we go. We could plug that in and make it all good. So that one looks scary, but not too bad. All right, they got one more here. That is a little bit more complicated. That is a little bit more complicated. But it's not going to be too bad. So we're going to try to look at it 2 or 3 ways, okay? 2 or 3 ways. Not that big a deal. All right. Again, what is our focus? Trying to get these x's together and by itself. That's our goal, to get it by itself. So I got to get these guys together. Well, the good news is they have the same denominator, so it shouldn't be that big a deal to combine these, right? So when you're adding and subtracting fractions, if you have a common denominator, then you're just going to simply add and subtract our numerators. So what is negative 4 plus 12? That's a 8. 8 over 7x. Okay, so we've simplified that down. Good. Got our x's in one place. Okay. We still got this issue of this x, and these 8, the 7, and the 6 all have to go away to get things going the way we want them to. Okay? So I could deal with any of those legally. Can do any of them I want to. But I think the 6 will be our best one first. Okay? As long as I don't mess up any of the basic rules, even if I make not the best choice, I can still get to the other side. Okay? So relax. So let's do that. Does that cancel? Good, good. So we got 8 over 7x. Yes, it cancels. Bring down my equal sign. You notice that all my equal signs are generally lined up the whole time. It's a good strategy. Okay, 8 and 7 got to go away. So you have 3 choices. You can get rid of the 7 first. You can get rid of the 8 first. Most people don't do that. You could get rid of the 7 and the 8 at the same time. We're going to look at all those scenarios real quick. So what we could do, first of all, is just get rid of the fraction piece of it. So let's get rid of that 7 so it just don't bother us so much. So first thing I want to do is instead of dividing by 7, I'm going to multiply by 7 on both sides. Okay? So, and when that happens, these 7s are going to cancel, and I'm left with 8x equals, there's the 168. Okay? Okay, and now I just got to divide by 8, and we're home free, right? Divide by 8 on both sides. Okay, and I like to hear both sides when you say that. So 16 into 8 goes 2, 8 goes into 8 once, x equals 21. Okay? You can make that happen. Was that the only way we could have done that? Not the only way, but just clearing out that 7 real quick made it a little bit, less anxiety, I bet, didn't it? So let's see, what could we have done? Could we have, let me put this over here in green. Let's do a little what if thing going here, okay? What if? Okay. So let's go back to 8 over 7x equals 24. What if we had multiplied both sides by 7 over 8? What would have happened then? Well, the 7s would have canceled, and the 8s would have canceled. And you would have just been ready to go. And then that would have turned in 21 as well. Because that's what we did. We divided by 7, then multiplied times 8. Or, I'm sorry, multiplied times 7 divided by 8. Got that backwards. Sorry. So you could have knocked out both the times by multiplying by the reciprocal. That means the fraction of that. So multiplying by the reciprocal could save you some steps. But that is a place that people kind of screw up sometimes. Does make some people nervous. So if that's an issue for you, don't do that. Okay? Just don't do that. It's okay. Let's see here. Oh, so next piece of this, let's look at it a different way. I want to come back up to the top. Is there another way we could have done that? Okay, with the GLAD strategy, it says once we want to clear the fraction. Okay, we want to get that thing cleared out. So what does that look like? What does it mean to clear a fraction? All right, so we got negative 4/7 x plus 12/7 x plus 6 equals 30. Okay. Well, What's the least common denominator? That'd be 7. What if we multiplied everything here times 7? Because that would cancel out these two fractions, but the rule says you got to multiply and divide all the way through. So we're going to multiply everything times 7 and see if this can make this a little bit easier looking kind of problem. Okay? So if we multiply everything times 7, what I'm going to do here is I'm just going to put a little 7 by each one of those, so it just kind of lets us know, hey, that's what's going on. So these 7s cancel, and so it reduced to 1, so that's negative 4x. Then plus 12x. Then 7 times 6 is 42. And then 7 times 3 is 21. Add a 0, 210. So are numbers bigger? Yeah, the numbers are bigger, but the fraction's gone. Yay! Called clearing the fraction. Just multiply through by the least common denominator, and fraction's gone. So I can do that first step, or I can combine the fractions first. If and that's easy if they're already like denominators, kind of thing. But then it's easy to go from there. We're just going to combine these guys, and then that brings us to 8x plus 42 equals 210. Minus 42 on both sides of the equal sign. Oops, went too far. 8x equals 68 divided by 8 on both sides, and x equals 21. So whichever method you end up going with, you still get 21. See what I'm talking about? There's some simple basic rules we got to follow. Now there's different strategies. You can get there by different routes, but all of these follow those 3 basic ideas of what you do to one side, you do the other. If it's addition and subtraction, you do like terms. If it's multiplying and dividing, you do it all the way through. If you stay within those, you will get to the other side and have a correct answer. We're all human, but you should have a pretty good shot. As always, I hope this has been helpful, and it's going to help you start thinking more freely about your algebra.